Suppose we want to take the integral of this rational expression. First of all, this is equal to the integral of px divided by qx with respect to x, since the degree of the denominator is 3 and it is more than the degree of the numerator, your px, so you don't have to do any long division. If they have the same power or larger power, then you have to do long division first. So let us break down the denominator into factored form. Let us factor the denominator. X cubed plus 4x is x times x squared plus 4. So it's a multiplication of linear term and quadratic term. We have a linear term to work with. And then you have a quadratic term. But please note that x squared plus 4 is not x plus 2 times x plus 2. It's a common mistake for students. They think, okay, now I can factor out x squared plus 4 and write it as the multiplication of x plus 2 and x plus 2. They are not equal to each other. X squared plus 4 cannot be factored out. So in this case, when we are using partial fractions, this is the third case of partial fractions. Case 3 of partial fractions, which says, well, if you have px divided by qx and the qx and qx is ax squared plus bx plus c, where b squared minus 4ac is negative, the discriminant is negative, px over qx is expected to be written as, on the denominator, just copy down the denominator. Your numerator is a linear expression, ax plus b. Okay, so let us go back to our integral. In this integral, we have a linear term and we have a quadratic term, right? So we should be careful about applying two partial fractions. This guy can be written as the integral of 2x squared minus x plus 4 divided by x times x squared plus 4 dx, which in turns can be written as the integral of, you have something like, let us call it k divided by your x plus ax plus b, ax plus b divided by x squared plus 4. Let me change the color for this guy down here to avoid any confusion later on when you're multiplying these, and then take the integral with respect to x. So when you take common denominator between these two fractions, common denominator, the common denominator is x times x squared plus 4. On the left-hand side, you have 2x squared minus x plus 4. On the right-hand side, you end up with k times x squared plus 4 plus x times ax plus b. Very good. Now distribute k into parentheses, distribute x into parentheses to find the values for a, b, and k. On the left-hand side, you have 2x squared minus x plus 4. On the right-hand side, you get kx squared plus 4k plus ax squared plus bx. Perfect. So now let us compare left-hand side and right-hand side. On the left-hand side, you have 2x squared. On the right-hand side, you have ax squared plus kx squared. What's the meaning of that? It means that 2 is equal to k plus a. So take a look here. You also have bx, which must be equal to negative x. So b is equal to negative 1. So we calculated the value for b easily. Now, at the same time, if you check 4k, 4k is equal to 4. 4 is equal to 4k. What's the meaning of that? It means that k is equal to 1. But since k is equal to 1, a becomes 1 as well. So we found all the missing pieces. Let us go back to our integral and take the integral. You end up with the integral of k, which is 1 over x, plus a, which is 1, x, and b is negative 1, divided by x squared plus 4 dx. Now we are basically using the elementary calculus to find this integral. Well, calculating the very first integral is not that difficult. You have the integral of 1 divided by x, which is ln of absolute value of x. This is ln of absolute value of x. But for the second integral, x minus 1 divided by x squared plus 4 dx, what should we do? Well, this integral can be separated into two integrals. So you have ln of absolute value of x plus, let me use a different color, the integral of x divided by x squared plus 4 dx minus the integral of dx divided by x squared plus 4. So here I divided x by x squared plus 4, and also I divided negative 1 by x squared plus 4 to separate these into two integrals. So remember that in algebra, if you have a plus b divided by c, this can be written as a over c divided by a over c plus b over c. So here you have a, and then you have your b. So this is what we did here. We separated this integral into the summation of two integrals. Why is that? Because it makes the calculation much more easier for me. This is the ln of absolute value of x plus, here if I use u sub, take u to be x squared plus 4, du is 2x dx. So you have a 2, you have a half. Move this a little bit down here. Plus a half integral of du divided by u minus, for this guy, we had a formula, right? When you have the integral of dx divided by x squared plus 4, it is basically a half inverse tangent. right? So here you have negative a half inverse tangent of x divided by 2 plus constant of integration. Let us take this middle integral as well. So you have a half ln of absolute value of u, which is x squared plus 4, minus a half times inverse tangent of x divided by 2 plus constant of integration. Using partial fractions to calculate the integrals.